I don't think I was there for those help sessions. So it's like question 11.
Mm-hmm. Let's see. Which page? Page 4. Yeah, this is one of those things where without a calculator, it's hard to visualize it. So I would say just kind of put things together a little bit. You know that absolute value of x looks like this, right? Now the square root, what's it going to do? It's going to give it a little bit of a curve. So it's still going to be a sharp turn because of that absolute value there. And that's enough for you to understand that, okay, I'm not going to have any issues with any breaks in the graph, but I will have a sharp turn. So therefore, it's not differentiable.
Okay. Same subject.
So what I did was I built my f of g of x first. So I inserted g of x into f because that's what they told me to do. So then this is my function here. And I just went ahead and I found the derivative of this function, just going through chain rule. And then I plugged in 3.
I got confused because it was like a chain rule inside of the chain rule, I guess, maybe. Or did you just boil it out? Like, what did you do to 3x minus 2 squared?
Yeah, it's a chain rule within a chain rule. So the outside derivative is that bracket to the 1/2, and then the inside derivative 1/2 parentheses to a negative 1/2.
Well, no, I understand.
Okay.
So I understand that how you got the original function.
Uh-huh.
Maybe taking the derivative of it, so I understand the first part, but then don't you multiply by the
Yeah,
inside?
right, inside.
Derivative of the inside.
So the derivative of my parentheses in here is going to be 2 parentheses to the first power times 6x. And we know this 4 goes away. That's just
6x.
because 6x is a derivative of this innermost portion inside the parentheses with the squared. Right? 3x squared's derivative is 6x. So imagine if this problem was by itself. Right? If asked to find the derivative, you would say 2 parentheses to the first power times 6x.
Give it to me.
Yeah.
Got it.
Okay, 58. At 58, we're told that variables b and h, these are variables, not constants, these are variables. With respect to time, that's a giveaway. Related rates here. We have the equation h cubed equals 4 minus 2b squared. And they give you a bunch of values. They give you dBdt, they're asking for dHdt, they give you h. So we know we got to do related rates. Let's go ahead and build our derivative first. All right, so h cubed becomes 3h squared, dHdt has to show up. 4 minus 2b squared, we go through chain rule. But in the end, we got to have dBdt show up there as well. That's the hard part. Once you get the derivative going, then you're using the information that they give you to try to solve for whatever variable you're asked to find. Now, I do need to find the b value using that h. And so when I plugged in h into the original equation to solve for b, I ended up with plus or minus. I got 2 different b values, a negative and a 6, -2 and a 6. And the way that I knew to choose the 6 was because in the beginning they said that variables b and h are positive. Yeah, so you can work through that and see if the steps make sense. The same way. You build your derivative with related rates because you know d over dt is already kind of given to you. And that kind of gives you a hint to use related rates. But there's product rule here, though. Got to go through product rule. With that x, y squared being multiplied together. And sometimes if you're looking for additional variables, values, you may have to insert back into your original equation to find those missing variables. So in this case, you do need x in your answer, the x value in your answer, and you have to use your original equation with what they give you with z and y to help you solve for x.
So these problems, they're not like multiple choice, but they're not FRQ, so they just
Oh.
practice.
Yeah, these are just for practice. It may be multiple choice, but these are problems that that were like on like different Quizlets that AP College Board put out. So I just copy and pasted a whole bunch of them. But yeah, this, I mean, if anything, this, if it shows up, right, it will probably be on the multiple choice portion. but it just didn't have the answer choices there. 13, we saw something similar on the recent test where you're just doing linear approximation, spend the time to find the derivative, find your ordered pair, find your slope. And then once you build your tangent line equation with the ordered pair 0, 2 and slope 1/4, then your final step is to plug in that decimal value 0.08.
This be like a calculator problem or not?
Yeah, this might be a non-calculated question. Because it's not too bad to do the 1/4 times 0.08.
Okay. Steve,
It's manageable without calculator. Okay, 59.
Did you, what about the one?
Oh, yeah, the bottom, just a little bit of interpreting here. So. The C function is a static value, and then C prime is a changing value. It's a rate, yeah. Yeah, a lot of stuff going on for 15. A lot of interesting relationships here that doesn't seem apparent, but we can kind of discover them as we read through the problem. So you got a function x to the 4th plus ax squared plus b. The graph has a relative maximum at 0, 1. And an inflection point at x equals 1, the values of a and b are. So you know a and b are unknown constants that they're not telling you. Relative maximum means where f prime is equal to 0. So let's set that off to the side. So why don't we just go ahead and set f prime, find f prime, set equal to 0, and see if that 0, 1 can help us gather any information about either a or b. And then inflection point means where the second derivative is equal to 0. So I can find the second derivative set equal to 0, plug 1 in for x, and that can help me solve for some other information. But another set of information that we can use to help us out is that we do have an ordered pair for the function level. So we do have x and y that we can plug in that can potentially help us find some information too. So if I plug, yeah.
Is there?
No, 0, 1, 0, 1 goes into the original function, not into the derivative. Because if I plug 0 into x, the 1 is for the y value. It's not the slope value. Right. This is the order pair at the function level, not at the f prime level. What we do know is that f prime of 0 is equal to 0, but that won't help us out because everything zeroes out. It doesn't really provide us any more information. Okay. 16, f prime is shown. Find the x value where the absolute minimum occurs. So if we can kind of sketch out what this graph looks like in terms of on a slope sine line, we know that above means positive slope, below means negative slope. So we know that this graph is rising until k, and then it's falling the rest of the way out. But it's definitely moving down a lot more than up because the area between k and m is a lot greater than the area from 0 to k. So we know that wherever it starts, it's going to keep going down, and it's going to go down further than where it started. So we know that at m, the absolute minimum is going to occur. Right. So let's give an example here. Let's say this is a particle motion problem. Okay. Let's say x of 0 is, let's say this object is moving along the x-axis. X of 0 is 4. Right.
Backwards waves.
Right.
So.
Yeah,
Because I feel like everybody's sick.
yeah.
I feel like I like avoided it though.
Yeah, cough's the last thing. I need to get rid of.
No. So the way that you describe. um, Like you explained it, like what are, like if it was an FRQ question or something like that, I'm just not sure I'd come up with something. I think I might get to the answer, but I might not, like, is it, how particular is it, would you say?
Um. Ask that question again, what'd you say?
Well, so it says, so we found that, you know, how questions will say like, find this and explain why. I'm saying, how particular are they about explaining why? Because I feel like I could get to the answer, I just don't know if I'd explain it.
Yeah, I mean, you can also, this is also basically a EBT problem. You can also just show that you're testing your endpoints and critical points. And then you're finding your absolute minimum. And with EBT, you don't have to really
Right.
produce a lot of words. You just have to show your work and show your steps. Yeah. I think wording is more important for like IVT and mean value theorem and goals. Okay, good. And CAD is just graphing it to, obviously you don't have to graph it. Yeah, you rarely have to graph anything on FRQ. The most is just being able to match the correct graphs.
I think I'm able to do it.
Okay. Yeah, so A, B, and C here connects IVT, mean value theorem, and roles.
So if you. So I understand that it would be 3 times because you know that if you have like a number up here and a number down here, it has to be connected. It's
Yep,
different-
yep.
Differentiable.
Well, it cannot be differentiable, just continuous for IVT.
Right, yeah. But it says that function G is differentiable, which means it's continuous too.
Yeah, you're right, that's right. Yeah.
So, you have to say IVT by IVT.
You don't have to, but
I mean, obviously it'd be good to.
I think, yeah, I think it's good too, because it could potentially, yeah, otherwise you have to you have to explain it. I think some Sometimes though, you are asked to justify it. And let's say they ask, how do you know, or what can you say to guarantee that the graph is going to cross through y equals 3 at least once? And so we can say, since f of 0 is equal to, sorry, f of, let me just pick an easier number here, f of 6 is equal to 2, and 2 is less than 3, and 3 is less than 5, and 5 is coming from f of 8, then by IVT, f of c is equal to 3 at least once on the interval from 6 to 8, something like that.
Right.
This could be what an IVT explanation could look like.
Mhm.
It feels, I mean, there's other ways to do it, but this is the most efficient way of showing that you are comparing the y values and that you are understanding where that interval, why we can say that it's on that interval. And then you have to also say a statement about continuity as something like that. Yeah.
Mhm.
But yeah, IVT can get a little wordy in terms of having to write out an explanation. Mean value theorem, whatever slope you can gather between the endpoints, that slope is going to have to live somewhere along that curve at least once.
Can you just go over C?
Yeah, so Rolle's theorem. I gotta find two values that have the same y value. Yep, yep, yep.
Is there, well, what's the relationship between Rolle's theorem and mean values? It's mean value theorem is with any slope and then Rolle's theorem is with just 0?
Just theorem, yeah.
Okay. That's what I was thinking.
They make that distinction with Rolle's theorem just because we're looking for slope 0 more often than any other slope, so it's so it gets its own category. Hmm. Okay. Good with 18? So 19, the function is sitting at a level above that 2t cubed, so first derivative will we'll strip away that integral. And the second derivative, you can apply power rules to get down to that 6x squared.
Mhm. I understand the problem. I just like skip information sometimes when I read, like I didn't see the 36T at all.
Oh, really?
Yeah,
Mhm.
like I think I'm gonna just try to be really particular.
Oh, you thought it was just the constants.
So really it's right, like, but it's just, I just assumed right for 37.
Oh, I see. Okay.
But. Sure, I'll be.
Yeah, you'll be fine. Make sure you get plenty of rest on Sunday.
The concept of it.
Okay.
I, like, wrote the 36.
Got it, okay.
So how is the question A different than question B?
Because with A, you have the f of x in front of you, so you're finding the area under the f of x graph. But the integral of f prime, we don't have the f prime graph in front of us, so we can't find the area of
Oh.
f prime.
So so it's the area of the F prime graph, basically. When you can't get that, you just go to the slopes of the graph that you do have.
So you have to do first. You have to make, if f is what's available to you and you're at the f prime level, you gotta go through the first theorem, make it f of b minus f of a, and then you can find those 2 points and
Are those answers the same coincidentally, or are they?
they're saying coincidentally, they're not necessarily related numerically. Right.
Okay, I got it now, I understand.
Good.
So when you're looking at the integral from 0 to 8 of 2g of x.
Yeah.
Is there a reason that you wouldn't pull the 2 out front and then multiply your answer by it? That was my first instinct instead of dividing.
Yeah, so the reason why I divided was because I looked a little further down and they want the integral from 5 to 8 and 0 to 5 with just f of x and g of x. So if I can isolate that g of x,
Oh.
it'll,
Yeah, so I understand that you're trying to isolate the g of x.
Yeah.
I just thought that you would pull the 2 outside of the integral.
you can, yeah.
But then when you multiply your final answer by 2, you get 8.
Well, we know what it's equal to. We know that 2 integral of g of x dx equals 4, right? This is a true statement. So, but everything else in the problem is just referencing integral of g of x dx from 0 to 8. So if 2 of this equals 4, then 1 of this is only equal to 2.
That makes sense. I get there on my own, but that makes sense.
Okay.
I don't understand how to do this one.
So,
What I've done so far is I've made like a little line that goes from 0, 5, and 8, just to visualize.
no, we just need to see that there is a 0 to 8, there's a 5 to 8, and there's a 0 to 5. So if you can establish this relationship. Imagine f of x minus g of x, just something, right? Just some connected thing here. So the area of some region can be broken up into 0 to 5 and 5 to 8. That's a true statement.
So
Right? Imagine you had some graph. Let's call this graph f of x minus g of x. Whatever that result is. And then if I want to say the interval from 0 to 8, which is the full region. I can break that into two compartments. 0 to 5. And 5 to 8. If I can let that be my baseline, then I can
So-
just,
alternatively, 0 to 5 is equal to 0 to 8 minus 5 to 8. Okay.
right. So if you think about it as three different things, then if I know this part and this part, I can just add and subtract to get to what I'm looking for. Are you taking this with extended time?
I am.
Okay, that's good.
I think it'll definitely help me because
Yeah, you won't feel rushed.
yeah.
Good.
Usually that's a big part of it, like, sometimes I just need to know that I can have
I-
extra time if
yeah.
I need it.
Right,
Because if I don't, then I'm like
right. Like anxiety
thinking
can come
about, I'm
in.
thinking about
Right.
running out of time,
Right,
I'm
right.
thinking about math.
Exactly, yeah, that makes sense.
The only thing that's throwing me off is that there's no 0 to 8 of f of x minus g of x. Is there? Or do you just get
We
that
have to
from
find, yeah, we have to build it ourselves. They give us the information where we can build it. Get to that 10. That first two statements can help us get there.
Which is really good. It's just equal to 7.
Yep, 22 is use substitution. And then it's good to practice with problems that have these constants and just learn to treat them like unknown numbers rather than variables.
don't worry about 25. I realize that's really a much more difficult problem than what you can expect to see on AP exam. So skip that one.
I'll do like one more.
Okay.
So how do you know that the 2 to the 8 power are canceling out?
Because one's positive, the other's negative.
Like if it's it's because the exponent's 8, right?
Mm.
It's gonna be a positive value once you evaluate it.
But there's a minus here,
Okay,
so that's gonna force the two to cancel out.
so then, oh, wait. So that case negative. This also. Got it. Thank you so much.
Yeah.
Appreciate it.
If you have any questions over the weekend, just send the question over to mine. I'll help you out.
Got it.
But otherwise, I mean, if you'll be there Sunday night, you can also ask questions during that time too, over
Okay.
Teams. Mhm.